Hi there, in this video we will learn how to sketch quadratic functions if the domain is given. Well, it's easy. First, you just have to ignore the domain givens. Sketch the graph as how you should usually sketch your graphs. After you have sketched your perfect graph, and then you look at the domains given here, and then just cut your graph according to the given domain. Erase anything that you don't want and just leave the ones that you want. That will be your graph. Okay, let's take a look. Now, what is the first step? First step is to look at the shape of this graph. So to know what does the shape of this graph looks like, whether it's a smile or set graph, you have to look at the coefficient in front of x squared. Now a here is 1. So when a is equal to 1, this is greater than 0, that means the graph is a smiley shaped graph. Second step is to find the minimum points. Okay, so what is the minimum point for this graph? To know that, you have to memorize this formula, which is negative b over 2a. What is the b for this function? The b here is 0 because there is no x variable here. That means the coefficient is 0, x. So 0 divided with anything is just 0. Next, substitute your 0 into this function, 0 squared minus 25, you get negative 25. So this means the minimum point is situated at 0, negative 25. Okay, this point is enough for us to sketch our graph. So draw your x and y axis and then plot your point. The point is 0, negative 5, which is situated here. X is 0, y is negative 25. So should it be a dense circle or empty circle here? Well, x equal to 0 is situated in this domain. So that means the value of x equal to 0 is included. So that's why we write a dense circle here. Right, next. The shape looks like a smile-shaped graph. So from this point, this minimum point, we should go up and draw this smile-shaped graph. As you can see, the graph does intersect at this x-axis. So this x-intercept, how do we find the values? To find the x-intercept, y is 0. So just replacing fx equal to 0 and then find what is the values of x. You can simply press your calculator or factorize this manually. So the values of x here is x5 and x negative 5. x5 and x negative 5. Now you're done. This is the perfect graph of this function. Now, the question gives you this special domain for the function fx, where the graph only exists at negative 4 until 6. And where is negative 4? Well, negative 4 is somewhere here. It's before negative 5. And where is 6? 6 is after 5. That means the graph only exists from negative 4 here until 6. So what should we do with the graph after and before negative 4 and 6? We should delete the other graph. But before that, look at the symbol here. Right, so this is x greater than negative 4. So here, there is no equal sign. That means we should draw an empty circle here. And at 6, there's an equal sign here. So that means we have to draw a dense circle here. Okay? After that, we can delete the other graphs. Delete all of the graph more than 6 and all of the graph less than negative 4. Okay, but at negative 4 here, we know that it must be a coordinate. Negative 4 is the value of the x, but what is the y coordinate at this point? So to know that coordinate, we just have to simply add in the fourth step, which is finding the coordinate of the endpoints. Look at the first endpoint, which is negative 4, and substitute x with negative 4. Negative 4 squared minus 25, and the value is -9. So this means that our coordinate is -4, -9. So plot your point here and write your number -9 so that it's easier for us to look at the range later on. And the other endpoint is x equal to 6. So just replacing the value of x with 6. 6 squared minus 25 is equal to 11. So the coordinate is 6, 11. That means right at 6, the y coordinate is 11. Make sure you label your points clearly so that it's easier for you to determine what's the domain and range of this graph. So what's the domain? The domain, you can simply look at the question. It's given to you. In other ways, you can also imagine that you're standing on the x-axis and then using your Superman rays, what is the smallest value that you see is -4 until 6. Okay? So this means that your domain is from -4, when -4 is not included because there's an empty circle at -4, until 6 because at 6 the dense circle is there. Now let's look at the range. To look at the range, you have to imagine that you are a Superman which is standing on y-axis. So you're standing, for example, on the right side of this y-axis, and then using your Superman rays, you see up and you will hit the graph. Until where? Well, your ray will only hit the graph until y equal to 11, because after that, your Superman rays will not hit any graph. And then you should go below and see until where does your Superman ray hit. And here you can hit both left and right sides, and the smallest value is -25. So how to write your domain? So how to write your range? The smallest value is -25 and it goes until 11. So at -25 there's a dense circle, so that's why there's a square bracket here, and at 11 it's also dense circle, that's why you should write a square bracket there. Why don't we stop at -9? Well, because -9 is not the largest value of y for our range, because after -9, here we still have graph. Okay, our Superman ray will still hit the graph. So the range will only stop when our Superman ray does not hit any more graph, like after 11, 12, 13, 14, and so on. Okay, so that's how you draw a graph when the domain is given, and that's how you find the range when the domain is given. Okay, so the other graphs, for example like cubic and surd graphs, you can do the same method, which is just sketch them as how you would normally sketch them, and then finding the endpoints and erase the other graph after and before those endpoints. Okay, so I hope you learned something from this video. Thank you for watching.